Okay, so today we're going to look at making molar solutions for biotech. There are some basic equations or a basic equation that helps guide you through most molarity calculations if you are starting from powder and making a given volume. So you obviously need to know what the molarity of the solution is. If you need any unit conversions to get you from one unit to another appropriately, you need to know the molar mass of the substance you are going to be making. That can also be referred to as the formula weight, and you of course need to know the desired volume that you are trying to make. So let's look at trying to make a 1.2 molar sodium chloride solution. Let's look at trying to make 100.0 milliliters of this solution. So how would we make that? Well, first of all, we've defined a couple of things. We know that 100.0 milliliters, that is our desired volume. We know our molarity that we're trying to make. We do need to remember that molarity is actually moles per liter. That's very important. And finally, if we're looking at this, we're going to be dealing with liters, but we're going to be making milliliters, so we're going to need the unit conversion of, in 1 liter, you have 1,000 milliliters. The last thing we need to deal with here is molar mass. Now, molar mass, you can look it up online once you are familiar with how it is calculated, but you should know how to calculate it from scratch because you will not always have online access. So sodium chloride is thankfully very easy to calculate. All you need is the periodic table. You are not expected to memorize the periodic table. You use it as a resource, and you need to know where to look on the periodic table to find this information. So sodium chloride is made of sodium and chlorine. So sodium has a molar mass of 22.99 grams of sodium per mole of sodium. And then chlorine has a molar mass of 35.45, oh, that's a really bad 35.45 grams of chlorine per moles of chlorine. And therefore, the molar mass of sodium chloride is you just add these two together, which would be 58.44 grams of sodium chloride per mole of sodium chloride. Okay. So those are the basic things. We've now identified all of the key components we're going to need in this calculation. And when you do the calculation appropriately, you will find that all of the units cancel out except for the mass. And when you're making molar solutions from powder, you need to know the mass because we use a balance to weigh out a specific mass, and then we dissolve that specific mass in its solvent. And most of the time, our solvent is going to be distilled water. So let's start with doing our calculation now. So we have 1.2. Now we could write big M, but let's really spell it out so we can show all the units being canceled out, because in biotech it's very important that you show every little step of the way so that there is absolutely no question of exactly what happened and how you came to that answer. So next, our unit conversion, we're going to need to know how many milliliters are in a liter, because our ultimate answer will be in milliliters of a desired volume to make. Okay, and finally, next we have our molar mass is 58.44 grams of sodium chloride per mole of sodium chloride. And then we need our desired volume. 100 milliliters is what we're trying to make. So liters cancel out, milliliters cancel out, moles of sodium chloride cancel out, and all that we are making is grams of sodium chloride, which is the amount of powder of sodium chloride we were going to weigh out. Okay, and so when we calculate this out, we find that you have 7.0128 grams of sodium chloride. Now this is ignoring sig figs. This is just our raw answer in our calculator. But now we need to determine really what we're going to really weigh out on a weigh boat, on a balance, to make this solution of 1.2 molar sodium chloride solution, 100 milliliters of it. So Now, the question is, what truly affects our sig figs? So, these two numbers are just conversion factors. We need to make sure we make our solution good enough to ensure that we have at least a 1.2 molar sodium chloride solution, but we could have a 1.20 molar sodium chloride solution. And this is a straight up conversion factor, no questions asked. Now here, with our periodic table information, that gives us 4 sig figs. We could use a periodic table that gave us more sig figs, but the periodic table that I referred to only gives us 4 sig figs. And then with the graduated cylinder we will be using, we know that that graduated cylinder weighs out to the 10th place, or measures out to the 10th place, so therefore we have 4 sig figs here. And so we know we have 4 sig figs. Sig fig 1, sig fig 2, sig fig 3, sig fig 4. So that gives us 7.013 grams of sodium chloride. So that is our sig fig answer. But then we have to be practical. Okay, so if we're going to be practical, we have to remember that the balance in our biotech classroom only goes out not to the thousandths place, but to the hundredths place. Therefore, in biotech, we would measure 0.1 grams of sodium chloride. So here we see that you would weigh out let's change the color so it's a little bit darker. Let's go. 7.01 grams of sodium chloride are going to be massed out in a weigh boat on our balance, and then we are going to be using that to make our solution. So what we would start off with is we'd put about approximately half of the desired volume, 100 milliliters is our desired volume, so approximately half of that, so about 50 milliliters, we fill with distilled water. Then you are going to transfer in the salt, but we would not try and pour it in straightforward. You would usually use a powder funnel to help facilitate the transfer. And then you would swirl to facilitate a full dissolving of all of the salt. And then we would rinse the powder funnel and the weigh boat to ensure that every little speck of salt that had been massed out actually makes it into the solution we're trying to make. And then finally you are going to QS it. QS the solution to 100 milliliters exactly, making sure the meniscus, the bottom of the meniscus touches the 100 milliliter line, not the top sides. We read to the bottom of the meniscus. And QS is just a fancy Latin shorthand of fill to. And again, we would use distilled water. Once you have done that, if you thoroughly dissolved at the first part, when you first had about 50 mils and you added in 7.1 grams of sodium chloride, and then you completely QS'd it appropriately and you thoroughly rinsed your funnel and your weigh boat, then you have now made 100 milliliters of 1.2 molar NaCl. And in reality, you could actually label it as at least 1.20 molar NaCl if you used a good enough technique. So, the final step we must remember is we do not store things in our graduated cylinders. We usually store things in objects like reagent bottles. So you would pour carefully your 1.2 molar sodium chloride solution into the reagent bottle of an appropriate size. You would add a piece of tape. You would write the concentration, 1.2 molar sodium chloride, first initial, last name, the date, and if there were hazards, that's where it would go. But this is salt water, so we can leave that off. And you have now made 100 milliliters of 1.2 molar sodium chloride solution.